Okay, the essential question for today's lesson: what are the key characteristics of solving an absolute value problem? Things you need to remember and look for. So keep that in mind as we're going through and solving some of these equations. We're going to start with some understanding of absolute value. Look at a couple definitions. So first, the absolute value of a number A is the distance between A and 0 on a number line. So this is the symbol we use for writing absolute value as a number. We use those two straight lines. So that means absolute value of A. An absolute value equation is an equation that has an absolute value expression. So we're going to be looking at some of those and actually solving them here in a little bit. Let's do a little exploring. So what number or numbers are 4 units from 0? So we're trying to explore what absolute value means. It's a distance from 0. So if you start at the 0, so here's our 0, and I go 1, 2, 3, 4 to the right, 4 is 4 units away from 0. But we could also go 4 units to the left. 1, 2, 3, 4. Negative 4 is also 4 units away from 0. So given the absolute value of x is equal to 4, which means the distance from x and 0 is 4 units, what values could x be? Okay, so number 2 is asking the exact same thing as number 1, just using the absolute value symbol. So that means that x is equal to 4, or x is equal to negative 4. So if I wanted to solve the absolute value of x equal to 9, this is just like number 2, that means x is equal to 9, or x is equal to negative 9. Last one to look at. Absolute value of x is equal to negative 2. Remember, absolute value measures a distance. Distance cannot have a negative value. Therefore, this would be no solution. So note, the absolute value can never equal a negative number. So we're going to use this in helping us solve some of our equations. Next, we're actually going to look at some solving of absolute value equations. There are 2 possible solutions. We have the positive case, and then we have the negative case. So this is what we were looking at in the previous slide. So let's take a look at what we were looking at again. So absolute value of x is equal to 4. So the x on the inside is either equal to a 4, or that x on the inside was equal to a negative 4. So let's do some examples. So absolute value 2x plus 4 equals 5. So remember, it's the inside piece that could either be a positive 5, so 2x plus 4 equals a positive 5, or 2x plus 4 equals a negative 5. So once you set up your 2 possible equations, you'll then want to solve each one. So the one on the left, minus 4 on both sides of the equal sign. Get 2x equals, so 4 is positive 4 minus 4 is 0. 5 minus 4 is 1. And you divide both sides by 2. X equals 1/2. The right-hand side, subtract 4 on both sides. Remember, in this case, that 5 was negative, so we have 2x. 4 minus 4 is 0, and then negative 5 and minus 4 is negative 9. And divide both sides by 2. So x equals negative 9 over 2. Or you can write that as negative 4 check your solution, you must check in the original equation. So we have to go all the way back up to the 2x plus 4 equal to 5. So we'll set up our check. And we are going to use the absolute value, 2x plus 4, absolute value, equals 5. And we plug the solutions that we got into that original equation. So we'll go absolute value 2 times 1/2 plus 4 equals 5. Now remember, when you are checking, you must use order of operations to do the check. So we're going to simplify the inside part of the absolute value first. So 2 goes into 2 one time. So that's absolute value 1 plus 4. Absolute value equals 5. And then that's the absolute value of 5 equal to 5. And then you take what the absolute value is, which is 5 equal to 5. So it did work. Now we check our other solution. Absolute value 2 times negative 9 over 2 plus 4 equals 5, using the exact same original equation to check your second solution. So 2 goes into 2 once, 1 times negative 9, so we've got absolute value negative 9 plus 4, absolute value equals 5. Absolute value, negative 9 plus 4 is negative 5. Absolute value equals 5. And remember that absolute value makes everything inside positive, measures a distance, so the distance from 0 to negative 5 is a positive 5, equal to 5. So that solution works as well. So our solutions are 1/2 and negative 9/2. Let's take a look at another example. Now note in this case, there's some stuff outside the absolute value. So we have a 3 on the outside and a minus 7. So that's 3 times the absolute value. 4x plus 2 minus 7 equals 11. You cannot distribute the 3. It does not work in this case because we have absolute values, not parentheses. So you have to isolate the absolute value part first before we can solve. So to isolate the absolute value, we are going to add 7 to both sides. We get 3 absolute value, 4x plus 2 equals 18. Now to get rid of that 3 in front, that's like multiplying, so it's 3 times the absolute value. So if we want to get rid of it, you do the opposite. So we're going to divide both sides by 3 so that the 3 cancels, leaves us with absolute value 4x plus 2 equals 6. Now it's a problem like the first one where we have the absolute value all by itself equal to a 6. So now we're going to take the parts on the inside and separate them into the 2 possible equations. So we're going to take the 4x plus 2, split it up, and do 4x plus 2 equals positive 6. And the other option, 4x plus 2 equals negative 6. And we solve those 2 equations. So minus 2 on both sides 4x equals 4. Divide both sides by 4. And you get x is equal to 1. On the right-hand side, you subtract 2 from both sides. You get 4x equals negative 8. Divide by 4 on both sides. X equals negative 2. Now we need to check both those solutions. See how they work. Remember, when you do the check, you have to check in the original equation. So off to the side over here, I'll do my check. So the original equation, 3 absolute value, 4 times x. So my first x was 1, so I'm going to plug 1 in where the x was, plus 2, absolute value, minus 7 equals 11. Okay, so that's what we're checking. Remember, the 11 is not going to change. We're going to evaluate the left-hand side of that equation using order of operations. So we'll go inside the absolute values. They work just like grouping symbols, so we have to do inside first, and we do the multiply part first. So 3 absolute value, 4 plus 2, minus 7. Checking to see if that equals 11. 3 absolute value, 4 plus 2 is 6. Minus 7 equal to 11. So then you take the absolute value of 6, so that makes it a positive 6. We've done the absolute value part, so now they change to parentheses. 3 times 6 is 18. Minus 7. And 18 minus 7 is 11. 11 equal to 11 does work. So 1 is one of our solutions. Then we have to check the negative 2. So we check the negative 2 the same way. 3 absolute value, 4 times negative 2 plus 2, absolute value minus 7 equals 11. So then we check to see if that works. Again, working the inside. 3 absolute value, 4 times 2 is negative 8, plus 2, minus 7 equals 11. 3 absolute value, negative 8 plus 2 is negative 6. Careful with your positives and negatives, that's going to be very important. Equal to 11. So the absolute value of negative 6 is a positive 6, so you have 3 times a positive 6 now. Minus 7 equals 11. You finish out the problem. 3 times 6 is 18. Minus 7 equal to 11. And 18 minus 7 is 11 equal to 11, so it does work. So negative 2 is also a solution. Okay, one more real quick. Another special case. Again, you want to isolate the absolute value first. So I'm going to subtract 5 from both sides. Subtract 5 from both sides. I get the absolute value, x minus 2. Absolute value equals 2 minus 5 is negative 3. And hopefully at this point you recognize that we have an absolute value expression equal to a negative number. And if you remember the note from the previous slide, when we were doing the exploration of absolute values, absolute value cannot equal a negative number. So if you get to the absolute value equal to a negative number, your final result will be no solution. So next are a few practice problems. Remember, these go on the left-hand side of your notebook. And we will take a look at them next class.